Let us calculate sector area for angles in degrees and radians. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll focus on sector area. We have three different diagrams here and we'll find what is the sector area. Let me shade the sector in the diagrams. Well, when you say sector area, we are really interested in this area, right? That is the sector, correct? In each one of them. So we have a triangle where the angles are given in degrees, another in radians, and then we have an equilateral triangle where you can find the angle, correct? So we are interested in finding the sector area in this particular video. In the playlist, you'll find many questions related to arc length, sector area, and segment area. So let's try to understand how do we find sector area when the angle is given to us in degrees. You know, area of circle is what? Well, area of circle is basically pi r square. Now, sector is a small area defined by the two arcs, which I'm shading now. Now, you see in this particular case, we are given the angle here, which is 70 degrees. So we need to find the area of this sector. From the symmetry, we can see it is 70 out of 360 of the whole area, right? So from the ratio concept, we can figure this out. So sector area is how much? Well, sector area in this case will be 70 degrees divided by 360 degrees, which is the total area of the circle, angle, and times pi r square. So that becomes general way of finding sector area when the angle is given to us in degrees, right? Now here we are given r is equal to 10. We can substitute, right? And so we get 70 over 360 times pi times r, which is 10 square. And you can simplify this expression to find the answer, correct? So that's not so difficult. So you can just simplify. I'll write it in exact values, which is, in this case, we have 700 over 36 pi. So cancelling by 4, 700 becomes what? 4 times 1 is 4, 30. 4 times 7, 28, 20, 175, correct? So I could write this as 175 over 9 pi. Clear? So that becomes the area. The units will always be in unit square. Perfect. So I hope you have understood the concept. So in any circle, find pi r square, the area of the circle, and the sector area is in the ratio of the angle subtended to 360 degrees or full angle of circle. Now let's take the second example, in which case we have a triangle whose sides are 12 each, right? So what kind of triangle is this? Well, this is an equilateral triangle, correct? Since it is an equilateral triangle, the angle theta is equal to 60 degrees, right? So angle theta is 60 degrees, and now we can find the circle area and take the ratio for which this sector area can be calculated. So as we did last time, I'd like you to pause the video, find the answer to find the sector area defined as shown by these hash lines. So let's find the area of the sector OAB. So it is equal to the angle theta, which is 60 degrees, divided by 360 times pi r square. And in this case, r is equal to 12. Substituting 12, we get 60 divided by 360 times pi 12 square. Clear? So now you can divide and simplify. 60 goes 6 times. 30 goes, this was 60, sorry. Goes 6 times, right? And we can further simplify, which is 1/6 of pi r square. 12 square is 144, correct? Dividing by 2, we can divide by 6 also, right? We get pi. 6 goes 2 times, which is 12. 24, 6 times 4 is 24. So we get 24 pi. Let me write, better to write 24 pi, right, as the sector area for the shaded region. Perfect. So see how we are fine. Okay, great. Now let's do the last example to find sector area. So we have to find the area of this particular sector OAB. This time the angle given to us is pi by 5. So angle theta is pi by 5. It is given in radians. In radians, full circle angle is 2 pi, correct? So that ratio will give us the area of the sector. So now let's find the area of the sector OAB. It is pi by 5 over 2 pi, full circle, times pi r square, right? R being 10. So we can write this as, let's simplify first, right? We can divide pi with pi, right? So we get 1 over 10 pi r square. Pi times r is 10. So that is 100 over 10 pi, which is 10 pi unit square. Is that clear to you? So that is how we can actually find the area of the sector, correct? So that is how we can find the area of the sector. So I hope the concept is absolutely clear. Perfect. So with that, we come to an end of this particular video. So here we actually found the area of the sector in different examples where the angle was given to us in degrees or in radians, correct? I hope the concept is absolutely clear. In the next video, we'll look into area of the segment, which is sector area minus the triangle area shown, right? Feel free to write a comment, share your views. In case you want to learn directly from me, you can always send an email on the address given. Thanks for your time and all the best.